Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 4-1 Part 1 homework solutions on exponential functions. For number 1, they want us to graph this exponential function using 3 to 4 points. So I usually use the x values from -1 to 2. I find that is kind of the ideal spacing for these things. So if I plug in -1, this is going to be 2 times 3 to the -1, which is 2 times 1/3, which is 2/3. And then if I plug in 0, 2 times 3 to the 0, well, 3 to the 0 is just 1, so that's just 2 times 1, or 2. And if you understand these exponential functions, you're multiplying by 3 each step you take to the right. So then this is going to be 6, and this is going to be 18, and you can double check that. So we've got -1, comma 2/3, that's somewhere around here, and then 0, comma 2, 1, comma 6 is up here, and then 2, comma 18, so let's see, here's 8, 10, 12, 14, 16, 18, all the way up there. So there's our function. For 2, they want us to graph this exponential function. I'm going to use the points with x values from -1 to 2. If I plug in -1 here, 1/3 to the -1, that's going to give me the reciprocal, which is 3. So 4 times 3 is 12. And then anything to the 0 power is going to be 1. So this is 4 times 1, which is 4. And since we have this 1/3, we're basically multiplying by 1/3 each step we take to the right. So 4 times 1/3 is going to be 4/3. 4/3 times another third is going to be 4/9. And then we have to graph these out. So we've got -1, comma 12. Let's see, here's 4, 6, 8, 10, 12. And then we go down to 0, comma 4. And then 1 4/3, a little bit more than 1. And let's see, 2, comma 4/9, that's roughly 1/2. And then draw the curve through those. And as you're drawing these curves, remember you have a horizontal asymptote on the x-axis. For this problem, we need to graph this function. So we're going to start with a table here. Now, a good set of x values to use with exponential functions is -1, 0, 1, and 2. Because if you plug in numbers that are too big to exponents, it's going to grow too quickly. So let's set up a table with those x values. So -1, this is 1/3 times 3 to the -1. 3 to the -1 is really just the reciprocal of 3, 1/3. So 1/3 times 1/3 is 1/9. And now we've got next 1/3 times 3 to the 0. 3 to the 0 is 1, so that's just 1/3 times 1, which is 1/3. Now we've got 1/3 times 3 to the 1. That's just 1/3 times 3. 3's cancel, giving us 1. And then we have 1/3 times 3 to the 2. So that's 1/3 times 9, which is 3. Graphing these out, we've got -1, comma 1/9, so that's somewhere down here. 0, comma 1/3 isn't too much different, it's a little higher. And then we have 1, comma 1. And finally, we have 2, comma 3. And we know this thing is just going to keep growing pretty quickly as we go to the right. And as we go to the left, we have that horizontal asymptote on the x-axis. For this problem, we need to graph the function 4 times 1/4 to the x. This is an exponential function. And we know that since the b value here is between 0 and 1, this is going to be a decreasing, decaying exponential function. So let's set up a table of values. We're going to use the x values -1 through 2. So going through now, we've got 4 times 1/4 to the -1. Well, 1/4 to the -1, that's the reciprocal of 1/4, which is 4. So really, we're just doing 4 times 4, which is 16. Next, we've got 4 times 1/4 to the 0. That's going to be 4 times 1, which is just 4. And now we've got 4 times 1/4 to the 1. That's 4 times 1/4, which is just 1. And next we have 4 times 1/4 squared. That's 4 times 1 over 16, which reduces to 1 over 4. So we've got -1, comma 16 all the way up here. And then 0, comma 4. That's quite a drop there. Now we've got 1, 1, and 2, comma 1/4. And we know that this is going to go down pretty dramatically and then taper out to a horizontal asymptote as we move to the right. For number 3, the costs of attending college are averaging a 10% increase every year for the last 10 years. how much will it cost to attend college today if it cost $20,000 10 years ago? So this is exponential growth. We're increasing by a percentage every year. So we need our exponential growth formula, AB to the t. And our starting value, A, will be 20,000. I know this was 10 years ago, but since they want to know about today, you're basically asking about 10 years from this start date. So if we start at 20,000, we can just use 10 for our t value, but we'll get there in a sec. For the b value, the growth factor, that's going to be the percentage, which is 10%, which is really a decimal of 0.1 plus 1. So we have 1.10 then for our growth factor. That's what we multiply by every year, times 20,000. And we want to raise that to the 10th power because we want 10 years of this. Plugging this in the calculator now and pressing enter. It's going to come out to $51,874.85 if we round up there. For number 4, in 2000, a total of 9.8 million passengers took a cruise vacation. Global cruise industry is growing approximately 8% per year for the last decade. How many passengers went on a cruise in the year 1990? So this is a little trickier. For this one, we're actually going to have to go back in time. But let's get our general formula first. So we have exponential growth because there's this percentage increase each year. For our starting value, let's just start with 9.8 million because that's what they gave us. For the growth factor, if we're growing 8% a year, that's going to be 8% plus 1, so 1.08 to the t power. So this will tell us how many people are going on a cruise t years from now. What time value should we put in? Well, since we're actually asking about something 10 years in the past, we're going to put in negative time, so negative 10. And let's see what the calculator has to say about this. Plugging that in here, we get back an answer of about 4.5, if we round it off to the nearest tenth, 4.5 million people. For 7, in a certain city, the value of a house is increasing at a rate of 16% annually. We want the value of a $100,000 house in 4 years. So for this one, since this is the annual rate, we're just going up 16% per year, we'll just use the regular exponential formula. So AB to the t. Our starting value of A is this 100,000. B, we're going up 16%, so that's going to be 1.16 for our growth factor. And for t now, we want 4 years, so let's plug 4 in there and use the calculator. Plugging all that in here, pressing enter, get an answer of about $181,063.94 if you round up. For this problem, the value of some industrial gear is decreasing by 10% each year. If the value today is 200,000, what's the value in 6 years? So this is going to be an exponential function because every year we have a percentage happening. So this is really repeated multiplication. Since we're doing this every year and not every so often, we're just going to use our standard form AB to the t. We don't need the half-life formula on this. So we have an A value, a starting value of 200,000, and a B value of, well, if we're decreasing by 10% each year, that means we're multiplying by 0.9. That's 100% minus 10%. And we're going to have the exponent t in there still. Next, we want to know the value in 6 years. So that's going to be 200,000 times 0.9 to the 6th, which we need the calculator for. So plugging this in my calculator, that comes out to approximately $106,288.20, and there's no approximate about it. That's actually an exact value. So there we go. For number 9, average temperature of a city has been decreasing 2% each year. If the average temperature there is currently 56 degrees, what will it be 15 years from now? So we've got decreasing percentage each year. This is just normal exponential decay. So we'll just use AB to the t. And we have a starting value, A, of 56 degrees Fahrenheit. For the B value, if we're decreasing by 2% each year, that's going to be 1 minus 2%. So that's going to be 98%, or 0.98. So we've got 56 times 0.98 to the t. For our t value, we want to know 15 years from now, so that's positive 15 for the exponent, and let's consult the calculator. Plugging all that in, pressing enter, we end up with about 41.4, if you round up, degrees Fahrenheit.